I don't know if I like the. Maybe the other one was better, but it's okay. Music's a little bit too loud. Okay. Um. Yeah. So let's see. So yesterday we started on our web automation project. So what we're trying to do is we're trying to automate some of our testing, like how we would test it manually. We're trying to automate some of that. So we picked our site. We picked the thing that we're testing, which is this pretty nifty, I guess, e-commerce site. Um, and then we decided on three features to test. One pretty easy, which is sign in, not sign up. Um, and then also a checkout flow, which is where we add something to our cart, and then we try to purchase it. Turns out it's a little bit easier too. It's not. It's basically the same thing as sign in, but a little bit more convoluted. Not even convoluted. It's just a little bit more extra steps, which is fine. And then we have a sign up newsletter, which I thought would be difficult because we'll have to deal with like email, and that's like an external site that we may have to go and check. But turns out it's not that hard. I mean, they don't send you emails, so we might change this. Maybe we. I don't want. I don't want to open. Um, let's not open it. But yeah, we may find a third one. Maybe a third scenario. Somebody suggested playing around with the carousel. This might be easy though. Why did it save? Let's remove these. All right. I want something kind of unique. It's something that not that it's not like normal. It's not just click, 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 and click because when you code that, it's pretty easy. But we want something difficult, something where we have to think outside the box. We may have to use other tools than our standard tools. But I can't find anything on this site that will give us the opportunity to do that. It's I guess that's why it's a very simple site, right? You got to find out something more difficult. But everything is very yeah. This is like pretty. It should be pretty easy to do. Um, the hard part maybe this may be the hardest part then, or like the most weird, which is you click on email, and then you try to open up your a special program. Like, how would you even automate this? Would you be able to use it with the same tools? Probably not. You'll probably have to use another tool. So maybe we'll switch it to that. But let's just get to automating. I'm pretty sure. So today was day two. Day one, we picked a site, figured out our tools, decided we wanted to use Python because I want to use Python. Just Chrome. We don't need to get too fancy with the other stuff yet, with the other browsers. And then we wanted to make sure we can automate like clicks, entering text, and checking elements on the site. So basically, these are the three basic requirements. There's a lot more advanced things that we'll work on in the future. So basically, we'll expand what we have. We'll make our tool more useful. So these are some of the things, and we'll look at each of them one by one, probably. And they may take more than one day, more than one stream to do because it can get pretty hairy. But we'll work on it together. We'll learn together. We'll make mistakes together. It'll be fine. But at least you get to see from start to finish. Um, you have day one VOD, so just watch that if you want to follow along. We literally started from a brand new Windows computer, nothing fresh. We installed all the software, so just follow the same steps and you should be able to reach the same result as day two. All right, so day two. So next time we are adding a test framework. Pytest is pretty popular, and the reason why we're doing that is because we want to automate the pass-fail results part of our manual testing. So when we manually test, we execute these steps on the site, and then we want to report back the results, right? We want to tell people, hey, this failed or this passed. And one way we do that is just to indicate it if it passed or fails, and then add some extra notes, log a bug maybe here, or maybe you have a separate tracker. So so we're gonna automate that, and let me just open up PyCharm, the project. And the way we do that is when we ran this code yesterday, which is just the automation code, just opens a browser, clicks on something, and just checks and stuff. Always download. Let's just do that. So when we did it yesterday, see, open the browser, saw get started button, and then clicked on it, and now it's verifying that the URL has something. The results that we get back here doesn't tell us anything. Like, we didn't add anything ourselves. We didn't say, hey, if you reach this step, print pass, or like tally up the results, like how many tests passed, how many tests failed. Like, we can write that ourselves, but why don't we just use a tool that has already done it for us, right? Let's not waste time. Let's just use some library, some framework that's already done it for us. You see, nothing happened, but we could have easily put it somewhere here. Somewhere here, like add a counter that something, a test passed, and then when you are in the main, you'll be like, hey, this number of tests passed, and this failed, etc., etc. So like, we don't want to write our own test framework like Pytest. Let's just use Pytest. It's very popular and it's useful, and it has all the nice colors, and it's basically a test runner. I think it has a test runner, so we want to use that. We don't want to write our own, basically. Maybe in the future we'll look into it, but I mean, at this point, I think the main goal is just to show how to automate something. All right, so let's get started. So the next step was to add Pytest, because we want to see some pass-fail results here with nice color coding. So far we only installed two kind of major tools, I would say, in this. So in our web automation tool, we have like two main libraries that we're using. Will be Playwright, and let's do Pytest now. All right, so on Windows, I don't really like using the terminal. I'm still getting familiar with how to use PowerShell. But luckily, the IDE PyCharm lets me install packages pretty easily using this thing. So let's install Pytest. Why don't they have nice descriptions? Oh, okay. Yeah, I think this is the legit one. Just want to. I'm wondering what all these things are. They just like mini libraries? Are they like? I guess they're like spin-offs, right? There's so many of these. But yeah, we don't need any of these other ones, I'm pretty sure. I think Allure is for like reporting, so I guess they combined it or something. Yeah, we're not worrying about reporting yet. That is that is in the future. So let's not worry about that. Plus, I have an idea for what to do with the reporting. It's something I wanted to do at work, but I didn't have time to do it, so I'll do it here. But yeah, we'll try different ways of reporting. Okay, so we don't need any of these. All we need is just a standard Pytest. And let's just install. Ooh, so many. Let's install the latest. Alright, I think I've used Pytest once or a few times. But yeah, I'll probably need to read the documentation to remind myself how to use it. Okay. I think this is a good stub to use. We'll reorganize the project a little bit. For now, I'm gonna do everything in main, but we will organize it in a way that others have done it before. There's just a design pattern or a way to like organize your code called the page object model, which should be good to look up. So we're gonna try something like that. But for now, let's just put everything in main. Let's not worry about organizing the code yet, because it's literally only three test cases, so it's not going to be too crazy. But yeah, we will write the automation first, and then worry about optimizing like readability and organization stuff later. Okay, so is it done? I think so. Alright, let's go to the documentation because I don't know how to run it. Is it just called Pytest? I think the command is just Pytest. So let's see, where are we? We are in the project. So I think we installed it in the virtual environment, so we got cd into it. Okay, and now our Pytest should be in the library folder. And yep, right here. So we should be able to start using it. So let's just test it out to see if it got installed. Usually this is like standard in all the libraries I've seen, so I think this should run. Term Pytest not recognized name. Okay, so it did not see it. Let's just double check Python can. Oh, interesting. Okay. I think we need to activate the environment. So seems like anytime I close the IDE, it like forgets. And I guess it deactivates my virtual environment. But I need to look up how to do it. Virtual environment. Activate Windows. The command, I think, if I remember correctly, it was this. So clear ls. So it's inside the scripts. Let's see what's inside the scripts. Okay, so we want to use activate.ps1. I'm pretty sure this was the command. So we do, or maybe we don't even need that. We'll see. Scripts, and then activate.ps1. Okay, I think this is what we use. You can see we have Playwright, we have pip, and we also have Pytest, so it should run. So let's activate. Activate just means we set the virtual environment as our environment. I'm pretty sure. Because running sure there's able on this is right. So yesterday we had to set, we had to change some setting. I still need to look at what it is. All I did was I looked it up on Stack Overflow what was the issue, and I copy pasted the answer that it told me to do, which was the safe answer. This one's a little bit more dangerous. So this one is fine. It's only restricted to like one process or like this session. So if I close IDE, I'll have to redo everything, which is fine. I'm fine doing all these steps just to keep it safe. But let's do this. All right, so that's I did something. I'll need to look up what it does. And then we activate it. All right, so we should be good. And now let's test it. Pytest version. Perfect. All right, so now we can use Pytest. So Pytest is successfully installed. And you know what you can also do? Like you can write a script probably to always run these two things on startup, but it's only two commands. We'll just look it up. Actually, you know what I would do? I'll save it. I'll save it somewhere useful. Sticky notes. I'm using sticky notes a little bit too much for stuff that I don't need to. I was gonna put in a comment, but I don't want to make it look ugly. I'll just use sticky notes. It's fine for now. Set execution. Alright, so these are the two commands that we will use. Actually, what we did was we cd'd into virtual environment. Alright, so we did these three basically on startup. Alright, save that. And so we have Pytest, so now we gotta start to integrate a bit. Let's change this test case a bit. Let's start writing stubs, and what that means is just let's start writing some empty. Oh wait, no, because if we do, once we use Pytest, it'll change how we write our tests. So let's not mess with that yet. We'll probably have to delete everything. So let's look at the Pytest documentation so we know how to use it. Getting started. Let's make it bigger. So a quick example of how to use it. So this teaches you how to use the assert. Makes it easy to write small, readable tests and can scale to support complex functional testing for application libraries. Okay. To execute it, all you do is Pytest. So one nice thing to do is just see what happens. What? What did it do? Test session stars. Okay, so I don't think there are any tests, but the you see what I mean by you get nice kind of output like pass fail results. So this is what we wanted. But yeah, I don't know what they were doing with this. Maybe that was just set up. Let's do Pytest again. I'm curious to see what happens if we go back to the main root project directory and do like Pytest. Like, what does that happen? Oh Jesus. Okay. All right. So maybe that's why. So there were no tests in the main, but we were in the virtual environment, and I guess people wrote their tests in their libraries that Pytest can understand. Yeah, it probably read some of these things. There's probably some convention. They read it and then and then it just ran it. So this is how it would look like if we had. Where was the results? Where were the results? Why did it disappear? But you saw it, right? CD the environment and then Pytest. Let's clear it. Pytest. So you see that? So all of these well, I guess this package, only this package had some test files that Pytest understood, and so Pytest just ran those tests because I guess it's smart enough to find the test and then run it. So it's good to know that 87 passed, one failed here. So look at that, pretty cool. So this is how our test will look like if we had 87 tests, if we had 90 tests. It's pretty cool. So that's what we want. So that's what we want for now. We probably want something more user friendly in the future, because not everybody will use a terminal to run tests. So, but for now, it's good enough, and it will help us when we're testing. Okay. All right. So what are we doing? So we want to know how to run it. Basically, we want a simple example. So I think what we need is we need a file that follows this convention, and then we need methods that or functions that have tests in front of them. So let's just get started. We installed it. Create your first test. All right, let's do it. Let's just do a new file like it says. Let's follow exactly what they said. So new file, Python file. What should we call it? Test. What is this site called? It's my store. Let's just call it test. Let's just call it. We can rename it later always, so it's fine. Let's test my store. Which one do we use? Unit test, Python stub. I'm curious to see what this looks like. We can always just let's just compare all of it. So we have okay, so Python file is just totally empty. New Python file. This is a unit. Let's see what this looks like. I'm curious to see what boilerplate code it uses. Okay, so imports. So unit test is like another test library. Okay. So this is not something we want, because we're using Pytest. We don't need to use that unit test. And then let's see what the last one is. A stub. What does that mean? How does the stub look like? Okay. wait, PYI. Interesting. What is a PYI file? Is another way to describe contents of a module that Wing has trouble analyzing. Code should be specified hints, some type hints for Python module to provide more information. So I think it's specifically for PyCharm. That's interesting. We can figure out how to use that later, but it's not something we need. I always get distracted by other stuff. But yeah, let's just use a plain Python file, and let's see what they do. So this is okay. I don't want to use it though. Multiple tests. So what I'm trying to do is to see if they have any of those like hook methods, and what I mean is like ways to do like precondition, like hey, before this test run does something. I thought they would show it, but I guess not right away. So I'm gonna read a little bit more advanced. Let's see. How-to guides, how to invoke test, how to use. I guess it's called. It might be called fixtures. Handle test failures. What is this? Unit-based test. Running Python unit-based tests are advised meant for leveraging existing unit test-based tests to use Python as a test runner and also allowing from that. Okay. Interesting. Don't think it's something we need yet. Okay, let's look. I don't think this is it either. Okay. So let's look at fixtures. Fruit salad, fruit bowl. It's an interesting example, but yeah. Okay. Fixture. All right. You know what? Let's just get started with theirs and see how it goes. We might have to look up something. All right. So say we're testing home. We don't need this. Like they haven't even imported. I guess you don't need Pytest for this. You just use regular assert. I'm wondering, is assert in Python default? Okay, yeah. So it is a default behavior. Okay. All right. So let's just check what it does basically. So we have a file that has test in front of it, so I'm pretty sure Python will understand it. So before, when we ran this, Pytest didn't recognize that we had any tests. So, but let's do it now, and it should find one, which is this Pytest thing. Yes, it found it. See, this is what we want. We want to be able to see failures. Okay, collect the one item. All right, so in this case, we should be able to just start writing our automation. So let's just transfer our stuff there. As a next step, let's transfer this test. Yeah, we don't need any of this. We have a test, so this will run. Expect, so we're gonna need to include some of this stuff. Basically we need both of these. Basically we need all of it. Let's just get all of it. I don't know what the re-library is. Python re-library. Oh, regular expression, okay. I didn't see that we need to use it. I don't think it'll break anything if we get rid of it. I'll separate regular Python stuff and Playwright and other library stuff. Alright, so we don't need this anymore. Technically, I don't think we even need a main file because now Pytest will be handling that. Actually, we do need a setup. So this is why I was looking for that like before method, because now like will this run? I'm curious because I'm pretty sure we need to use Pytest to get the starting code working. So we're not gonna do this. We're not gonna do this. All we want to do is yeah. There's like oh, so that's all we need. Re okay. Import re. So there's no way like we can't pass a page here, so this won't run because we haven't even set up the page. So yeah, I need to look it up. Pytest how to set up before hook methods. Okay, so apparently there was something here that I missed. So hook function validation is Pytest calls hook functions from registered plugins. So what we want is we basically want an example that shows us how to structure our code basically if we use Pytest. So what we only know now is we know how to run it and how it can find test files, basically just with naming conventions. But like this won't run. Like if I do this, this will break because page does not exist. Like we did not create a browser using Playwright. See, page not found. So fixture page. So yeah. All right. So we need to figure out where we'll put a set of code. Because it might not be in this main. It might be something from Pytest itself. So we want to look at their library examples. Always helpful. Introductory examples, we saw it all. Yeah, this is not what we need. It's a little bit too simple. How to write and report assertions in tests. No, we know how to use assertions. Okay, so Pytest has their own exceptions. Context sensitive, not. So this is not what we're looking for. This is all useful for in the future, but we want to figure out a structure. For basic fixture setup example, yeah, I think this is what we need. Built-in fixtures. Okay, capture as text output to file descriptor. Okay, so this is not, I don't think we need any of these yet. I have some ideas for possibly using these to help us, but I don't think it's the right move. It might be a hacky way to get something fixed. Perspective of the text. Inside class. This can also be affected by our use. Jeez, this is getting a little bit complicated. I thought Pytest came with it. But it looks like we may have to write our own. Let's look a little bit deeper. Right, I guess I'm used to like unit-based tests with Pytest. So unit tests have the setup and teardown stuff that we're looking for. I thought Pytest had it. Oh, so then there are also some downsides to using unit tests and not purely Pytest. So we're gonna have to make a design decision. Like, do we want to use unit tests with Pytest, or do we just want to use pure Pytest? Can we get the functionality that we want? Basically, the setup and teardown that's in unit test. Basically, all of these things. These 6 hooks. Like, are we okay? Possibly writing our own code to do this instead of leveraging unit tests, because we do lose out on some of these things. So parameterization just for data. Yeah, so we don't want to lose out on Pytest. We custom hooks. Let's so if we're unsure, best thing to do is just look it up. Let's see what other people have done. What do they think about unit tests with Pytest, browser, web automation? And then the second search thing I want to do is adding setup and actually some people call it before all and actually before test and after test to Pytest. So yep, this is a lot of people asked it too, so that's good. I asked, this wasn't a question per se, it was more let's make it a question. Is using unit tests with Pytest good? And then you get answers. Well, not really. So let's look at this one first. I want to run additional setup and teardown checks before and after resizing. To see, I've looked up feet. You're not sure if they're the correct approach. You need to run a setup code prior to each test. Basically what we're doing, what we want to do. Py.test fixture technically adequate method achieved. Okay. So yeah, we're basically writing our own fixtures. Code that will run before your test, for example. Okay, so auto use will automatically invoke for each test function defined. So I've used yield before, but so one thing so while reading this code, I don't understand how it just by adding this. So this code runs before the test. Okay, that makes sense because auto use is true. And then once you yield, what it does is it goes out, it basically stops executing this method and yields, basically gives control over to something else. But when does it come back? That's what I want to know. I don't remember. All right. See, we're learning Python as we do this project, which is good. What is the use of yield keyboard in Python? What does it do? For example, I'm trying to understand this code. Yield, and then returns something. Distance, okay. What happens when the method getChild candidate is called? Is a list return a single element to call William? To understand what yield does, you must understand what generators are. Right, okay. And before you can understand generators, you must understand iterables. Okay. How long is this answer? It's, oh wow, jeez, it's long, but it's okay. It looks pretty easy to, it looks organized, so let's read it. When you create a list, you can read its items one by one. Reading its item is called iteration. Yes, that makes sense. My list is an iterable. When you use a list comprehension, you create a list, and so an iterable. When you use a list comprehension, I don't really know what that means, but I guess when you use a list, basically what it's saying, you create a list, and so an iterable. Yes, that makes sense because the list is an iterable. Everything you can use for and on is an iterable. Yes, these are handy. These you can read them. Oh, but you store all the values in memory is not always what you want to do. Okay. So generators are iterators, a kind of iterable. You can only iterate over once. Oh, generators do not store all the values in memory. They generate the value on the fly. Okay. So this is a generator. Okay, so it's generating numbers, I think, from 0 to 3 to root 3. 3 to the power 3. For I in generator, print that. It is just the same, except you used curly braces instead of. Oh, okay. So imagine if this were a list of items, but we're calling it a generator. You cannot perform for I in generator a second time since generators can only be used once. They calculate 0, then forget about it and calculate 1, and end calculating 4 one by one. Okay. Yield is a keyword that is used like return. Yes. Except the function will return a generator. Oh, okay. So create generator. My list, okay. And then yields this. So it returns a generator. Okay, so my generator equals create generator. So this will be a generator, I guess. You're returning a generator. Okay. So probably all of this. So basically it's returning this from what it looks like. Okay. Here it's a user example, but it's handy when you know your function will return a huge set of values. Okay. To master yield, you must understand when you call the function. The code you have written in the body, in the function body does not run. So this stuff does not run, is what it's saying. Call the function. When you call this, the code you've written does not run. The function only returns the generator object, which is this whole thing here. Okay, this is a bit tricky, okay. Then your code will continue from where it left off each time 4 uses the generator. Right, because it only returns one thing once. Now the hard part. The first time the 4 calls a generator object created from your function, it will run the code in your function from the beginning until it hits yield. Then it will return the first value of the loop. Okay. Then each subsequent call will run another iteration of the loop you have written in the function, return the next value. This will continue until the generator is considered empty, which happens when the function runs without hitting yield. When the function runs without hitting yield, that can be because the loop has come to an end or because you're no longer satisfying if else. Okay, so, okay. Generator, here you try method. Here you create a method of the node object that will return the generator. Okay, right, because if you view, that means that the method is a generator and you're returning a generator. Okay. Here's the code that will be called each time you use a generator object and each time you use whatever was returned here. If there is still a child of the node object on the left, and if the distance is okay, which is basically what this if statement is saying, return the next child. Okay, and this is the same thing but for the right. But if this is false and this is false, then the generator has run out of things to return. Right, okay, so that makes sense. Caller, create empty list and list with the current object reference. Loop on candidates. Okay, get the last candidate and remove it from the list. Node equals candidate.pop, so candidates. While result candidate, this looks empty though, right? So this will never run. Oh, they contain one element at the beginning. The self. So results is a list, candidates is self. Okay, get the last candidate and remove it from the list. Alright, so you got self, notice self. Get the distance between object and the candidate. Distance equals node that get distance object. Okay. If distance is okay, result dot extend. Result is a list. Extend. I need to remember this. What is extend list Python? It just adds something, right? Adds all the elements. Okay. To the end of the, okay, yeah, that makes sense. So it just adds that. Add the children of the candidate in the candidates list. So the loop will keep running until it will have looked at all the children of the children of the children. Jeez. Of the children of the candidate. Oh, jeez. Candidates that extend. Okay, candidates is a list. And then it adds node that get child candidates, which is this thing. It's very interesting. Very interesting, but I guess the thing to remember is that this is just returning one item from here, and then the next time it loops, it'll get the next item if all these conditions meet, because you're basically iterating through the list, but once you go through one item, you don't remember anymore one, you go to the next. Okay, it's a little bit tricky to use. I can tell. It's 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 almost like thinking about it like recursion. Like you kind of have to get your mind wrapped around it before you truly understand it. Okay, but okay, so I think we understand what yield does, which is fine. So back to our Pytest thing, we're trying to figure out how to have like a before all and after all method that will basically run some steps before we actually run the test, like some setup steps, for example, or some cleanup steps after the test. So this person says all we need to do is create a generator. So this is a generator. Now that we know, as long as you use yield in a method, it makes it a generator. And a generator is just a list. It's just an iterable, let's say a list of things, but you can only like access one thing once. Okay, so code that will run before your test, because auto use equals true, so this makes sense. So files before equal something, and then yield. Yield is a return, but it's returning nothing. This is what like gets me. So it returns nothing. So yeah, let's look at another example. Let's look at another example. Okay, right. So we're starting to see a pattern. It seems like to achieve what we want, it's called we gotta use the fixtures features. Run before and after test. Okay. I'm trying to see if there's another way to do this, but it looks like all we need to do is this. Let's read the explanation. I'm curious to see this part. So from the docs, you may want to have fixtures that get invoked automatically without declaring a function argument specifically, or a use fixtures decorator. Therefore, this fixture will run every time a test is executed. Setup. Fill with any logic you want. This logic will be executed before every test is actually run. In your case, you can add your assert statements that will be executed. Okay, yield. As indicated in comment, this is where testing okay, so they don't go further to explain. So if we read what yield meant and what it's doing, it's returning something. So this time it's returning nothing basically. So it should give control back to the test. I just don't know when this happens. Did it have anything? It seems like you end it. Like it's a return statement, so you end it, right? So why would you have anything down there? We're gonna take a look at another example just to see if they do it the same way or if there's a different way to do it. Knowing Pytest, test. Okay. All right, let's look at a different example. Okay, so it looks like we have two options. So this is the thing that I'm used to, the setup teardown from the unit test style, and then there's also Pytest style. So I think we'll try Pytest. It's something we haven't done before. So it's starting to look like this is what we need. Pytest auto use fixtures. Let's look at this. Is it? Oh, that always sucks. Yeah, let's not use this. Has you complete cover, so okay, so let's look at their link. Oh my god, are you serious? Okay. It's okay. No, this is not what we want. We want to use fixtures. Auto use. My auto use fixture, the test is in the same scope. Let's also just look at how a Python fixture looks like. Um, okay, let's go back to fixtures. In the literal sense, are each of the arranged steps in data. So basically, it's where we prepare stuff for our test. The gist. So it can even be for like after test cleanup, it seems. This can mean preparing objects, starting killing services, so that'll be at the end, entering records in a database, and things like that. Well, wait, cleanup is where a test picks up itself. Oh, okay, so they broke down a test as arrange, act, assert, cleanup, right? So arrange is like the precondition, act is the testing steps, assert is the expected results, cleanup is the cleanup. And the fixtures lie in the arrange, it looks like. At the basic level, test functions request fixtures by declaring them as arguments. Hello, how are you doing? This is day 2. We're reading a lot of documentation. Just trying to figure out how to use fixtures for our test right now. So we installed Playwright and Pytest, but now we're trying to figure out how to use fixtures so that we can run steps before our actual testing steps. So yeah, just a bunch of reading so far. Just trying to understand before we write some code. Okay, are defined, they don't have to be limited just to yeah, I don't know, is that something that we don't do on day 2? I felt like I was reading it and yeah, it looked like it was something that we needed. I mean, we could have, so we were trying to automate like these 3 testing steps or these 3 test cases, and then this is the test site that we're playing around with. Like technically we could have done it all inside like a main. Just write all of them and then call, like write 3 of these for each test case and then call it all in main. But we wanted to use Pytest, and I don't know. It just felt like we needed it, and I guess I wanted to explore around with it. We may not even need it, but it just felt like it's something that we will need in the future. Gotcha. Okay. Yeah, we'll see how it goes. Because I'm so used to, I don't know if you use like unit tests and they have this setup and teardown. So I guess I haven't really, maybe I haven't shifted into like Pytest stuff. Yeah, let's try it and see how it goes. Yeah, I'm basically trying to recreate the before test and after test stuff with unit, but like with unit tests. But I want to use the Pytest way, and apparently it's you use fixtures, they're auto use fixtures. So yeah, we're gonna figure out how to do that. And so we we went down a rabbit hole trying to read what yield does, what generators are. So, yep. Now we're going back to fixtures. Yeah, it's a little bit hairy, but we'll see. We'll see. Which one was I using? I remember reading a range, so I think it was. Oh, it was this one. Okay. So back to fixtures. So basically, it's a setup for the test. Okay, so let's see how they use it. We can tell Pytest that particular function is a fixture by decorating with this. Okay, so now we know this is a fixture. Yeah. Day 2 of we're trying to write this automation tool just to do some basic stuff. We want to use Python. We wanted to automate in Chrome, and we just want to do the basic. We can click on stuff, just fill out forms, and check stuff on the site. So basically, our 3 scenarios is just sign in, adding this to the cart, and then going through checkout. And the last thing is just signing up for the newsletter, which turns out it's actually not as convoluted as I thought it would be. I wanted to do a kind of a tricky one where like maybe you have to open up a new like a desktop app and then try and automate that as well. But it turns out it's the site doesn't do that, so I don't know, we may change this part. But yeah, right now we're trying to figure out how to use fixtures and get our prepping our test basically right now. Okay, it's not this one. I need to pull this one in. No, I keep losing my tabs. All right, this is the one. Let's put it first. Okay, so this is a fixture. Okay, so it looks like you don't need to use yield. So yield is not a requirement. That's only for like generator stuff. So this one returns fruit object. Okay, and then how do you use it? So this is the test function. Assert my fruit in fruit basket. Okay, so you're gonna be passing 2 things into this function. You have 2 fixtures. Oh, they pass the fixtures into the okay, they're parameters there. Okay. So returns a fruit and returns a list. Returns a list with 2 items, 1 banana and 1 apple. Okay. So I guess that is how you use fixtures. You just put them inside the parameters. Okay, so then inside the test, you can assert my fruit. So I guess this is how you pass in data. Okay, so that's one way to use fixtures. Tests don't have to be limited to a single fixture user. Okay. Yeah. I don't know how long this project will go. I said, so at the beginning of the stream, I was like, we can do this in 4 hours, but we'll see how it goes. We're reading so much documentation that maybe not, but you know, it's good to learn this stuff. It's good to we'll need to use it in the future anyway, so it's good to just understand what it's doing. Okay, so so this is a basic example, which makes sense. Requesting fixtures. How do we tell Pytest what tests and fixtures need? Okay. Text functions required by declaring them as arguments, and all right. So there's one way to do it. Depends on a test to tell it what fixtures it needs. Depends on a test. On a test to tell it what fixtures it needs. So to build it, we have to make the test request. Okay. We have to list those fixtures as parameters in the test signature. Right. So that's what it did, right? It's the same thing. When Pytest goes to run a test, it looks at parameters in that test function signature and then searches for fixtures. Okay, that makes sense. It runs those fixtures, captures what they. Okay, and passes those. Oh, okay. You know what? That actually makes sense now. Why, when we try to run this, there was an error. It was like, hey, this fixture was not found. So it thought this was a fixture. So it expected some kind of fixture up here that will create the page for us. Basically, it was looking for something like this. Like we needed a fixture to create the browser for us. Okay. All right, we're making progress. I think we're getting kind of close to what we need to do, but let's learn a little bit more about what fixtures are and how to use it. Okay. So now we have two objects, two classes. We have one fixture called fruit bowl, which just returns 2 items. Try modifying and find that house and just read. Ah, you mean like these examples? Yeah, I think that makes sense for sure. And then we can like, yeah, that is a great idea. Let me, I guess we can do it here. Let me just, all right, so let's make sure that this still does high PyCharm. Okay, so that's good. All right. Whoa, what? Oh, okay, please don't break anything. Okay. All right, so this is gonna get a little bit messy, but all right, so let's see. So this should work. Oh no, we might as well just put it in a separate test file then. All right, so we'll just call this test example. All right. So we have a class, we have a fixture, we have a test method here, and I don't want to run this. So let me do that for now. All right, so now this is all we have. Let me see. All right, so let's try to run Pytest. All right, let's see what happens. Clear, clear, clear. So we have one test, and it will just assert fruit.cube for fruit in fruit salad.fruit. All right, let's just run it. Okay, so it recognized this, but let's see which example did we actually use? I think, okay, I think we were looking at this example, right? But yeah, okay, so requesting fixture that the test, and then searches for fixtures that have the same name. Okay. Fruit bowl. So this is how you request them, right? You just make sure you have it in the function signature. Once Pytest finds and runs those fixtures, captures what they returned. So this one returns a list of fruits and passes those objects in the test function as arguments. So now you can start using fruit bowl. Fruit salad equals fruit salad, and then you pass in. All right, I don't know what the star. What does star in Python do? Is it like some kind of? Oh, is it index? Oh. Okay, right. Okay. Okay, so this is like where was it? All right, so this is No, no. Let me see. Python star. Need to find the right keyword. Star in front of variable. I think this should help. So it's an operator with more than one meaning attached to it. Okay. This is the same thing that we had. So not multiplication. Listen to is a repetition operator. Huh. Function. Okay, so this is not what we need. So what they did was variable. It called the class constructor, and it passed in a list. But why did it need that? Fruit salad, fruit bowl. Why do you pass in the star? Let's look at a different one. So this is not okay. Calling the function. For example, let's say we code like this, okay. So this will print out any random number of arguments that get passed in. You can pass the list L into foo like so, right? So this is exactly what we were doing. So what does it do? So this is a list. So does this turn it into some kind of tuple? Will be a tuple. Okay. Of extra parameters that was applied to the function. Alright, so double star is dictionary, single star is a tuple, which I think it's just tuple in Python. It's different from a list, but why is it? Tuples are stored multiple items in a single row. Alright, this one. Well, tuples are immutable, so they can't change. Lists are mutable. Cannot be changed while the list can be modified. Tuples are... Okay, so I guess we can consider like a list. Splat operator? Splat operator. Splat operator. Python. What's the current name for that in... Okay. Okay, so it unpacks. Okay, it unpacks argument list. Let's go keyword expansion. Okay. So it lets for like arbitrary number of items to pass in, right? And then the star will just, I guess, splat it into a list. Okay, let me see. Is there another one? Splat unpack. Unit operator can be used in extent. What it does in the give? I don't think this. Let's look into one. Okay. Um, I just skipped over this answer because it's hard to read. This was the best, I think, but all right. So let me see. Okay, so we know it can receive an arbitrary number of arguments. So it receives 2. I just never realized that you pass it in like that. That's what you were looking at before, at least. Okay. Using splat operator. I'm trying to figure out like why when it called this, like you passed it in. I thought you didn't need to. I think we're getting closer to one of the answers which said that it turned it into a tuple. I don't want to watch a video. Let's see, maybe this one. Right, so why did they put the star there? I'm trying to understand this one. I have a code. Function list. So you have a function takes 3 arguments, and then you have a list with 3 arguments. If you call function list, that means you pass the list as a first. Okay, yeah, that makes sense. Okay, the second, third hand. Okay, so the star will the splat will unpack it. Gotcha. Okay, yeah, that makes sense. Thanks. Yeah, that definitely makes sense. Okay, so now we get it. So it's like use the star to unpack, and so instead of just sending instead of sending a list here, which can take like multiple arguments, you splat it, I guess, and then you're actually sending two now, right? That's what you meant. Yeah, that makes sense, I think. All right, so fruit salad equals that. So now you're sending 2 here. Cool. Okay. Sending 2 there. Fruit salad equals fruit salad. All right, so now this is an object. So now this is a fruit salad object. Okay, and then you assert fruit.cubed. All right, so for fruit, I need to get used to this this syntax. But so for fruit in fruit salad, that fruit is okay. All right. Let me check this. Python return true if all items in the iter are true. Oh, okay. So it just checks if everything is true or false. For fruit in fruit salad, that fruit salad. For fruit in fruit salad, that fruit. So fruit salad, this object. So right now it's this dot fruit equals fruit bowl. We pass in 2. We're passing 2 things. So we passed in 2 fruits. Self.fruit equals fruit bowl. So I'm curious to see, like, would this be a list, or just one of the fruits? Because if we unpack it, where was it? So right here, we unpacked it. So we have two fruits now as arguments. So yeah, I'm curious. I'm curious to see what it actually is. I guess we could run it and just check. This was the example, right? Yeah, I don't know why it was that confusing, but yeah, I think your explanation definitely made the most sense. Like, yeah, because it wasn't just like this was working with this together. Like there was a reason why you needed to unpack this in order for this to make sense. Yeah, I'm gonna run it because I'm very curious. I'm curious to see what actually gets saved here. Because there's multiple arguments, but you're not I'm wondering if this is a list or just like one fruit. I'm very curious. Always be a tuple, regardless of whatever you pass it in the thumb. Okay. Gotcha. Okay. All right. So let's see. So we have a test. So if we run Pytest, this should run this piece of code, and it will check this. Yes. Okay, but I want a little bit more info. So let me see. I want to know what this is. Like, what is so let me do we already have a fruit salad. So, but I'm curious to see what what exactly this is, and like what type. All right. Let's see what exactly that is, and then I haven't even looked at what cube fruit is. Self.cube fruit. So it calls this for fruit, and oh, so it's actually a list or tuple. Okay, so it's not just one thing. Fruit.cube. What does cube do? Fruit.cube. Oh, this. Oh, okay, so then it. Okay, so it just makes it true. So then once it's all true, then this will be true. Okay, so it seems like it's a list or tuple. Let's check. Okay. So would this mess it up if it's a tuple? Let's see. Did not show. I guess Pytest probably has a setting where I need to turn on like output or something. Let me see. Pytest turning on what do you call it? Standard output printing. What other language have you used in the past? I've used so I studied Java, use it a little bit to test, and like a long time ago, like C++ and C in school. So yeah, mainly Java, Python, but it's been too long since I've used Java. So there's a lot of like new syntax, like a lot of more modern, nice syntax that kind of looks like yeah, so I've been behind. Like last time I checked, I was like in Java 8. I don't know what Java version is out now. Java version 16. Is it that long ago? It's only been a few years, but yeah, I haven't used it in so long. I used to really like it because I felt all the curly braces, all the classes, like it made sense. But then I started using Python, and it was just, I don't know. I used to have a thing against Python because of the indentation and just not enough words. I guess I like to type a lot, but no, now I like Python, and I'm trying to get more familiar with it. Yep. Trying to get the test. Yeah. Are you also like what's your main language that you like to use? Um, oh right, if it fails, it might actually show us the output. You're right. Um, okay. All we need to do is just change this to false then. Okay, so we got it to fail. Fruit salad. Okay, there we go. Test now fruit object and this looks like a tuple. Yeah, it looks like a tuple of two items. Okay. Alright, cool. So this is a tuple. Oh yeah. Okay, that makes sense. I got so hung up on the fact that we were unpacking it that I forgot this is a tuple. Okay. That makes sense. But yeah, okay, that's good. We understand this. Yeah. This is why there's so many rabbit holes that we can go into when we're coding. It's like we're just reading up on stuff that we don't know, and then what we were trying to do actually it takes longer. But yeah, this is good. Now I have an idea what fixtures are, how to use them, getting familiar with tuples. All right. I was just saying I used to like Python, then I learned to love. Ooh, really? Wow. Okay. Yeah, I like braces too. But yeah, I don't know how I feel about going back to Java. It might be a bias thing. Like I like the language that I used the most recently because I'm more familiar with it. So right now Java and especially like C++, I would be super intimidated to start again because I need to look up all the syntax. I remember how to do all those standard things, but yeah. But yeah, I never had a problem with braces. I liked it. I actually had a problem with indentation. I thought it wasn't structured enough and it was confusing, but I've since learned to enjoy or appreciate the conciseness in Python and like readability. Rust. Interesting. Okay. What kind of programming do you do with Rust? Not the game. Programming. Rust multi-pair jump from program puts Rust emphasize for memory safety. Concurrent. Okay, I wonder what it's used for. Concurrency in memory. What do you use it for though? Yeah, I heard I remember in university it was like so we all came from Java and then we had our first semester using C++, I think, and then the professor was like, oh yeah, if you know one language, like especially like Java, then we'll just do a 2 week crash course and you'll be able to understand C++ easily. So yeah, I think that's pretty true. Unless it's like a totally different way of understanding a language, then maybe that will be more difficult. Like JavaScript, like I still can't get my head around like the callbacks and stuff. I never practice it, so maybe that's why I don't like it and I'm biased against it. But yeah, I know it's super popular and people use it. I hope to do a stream in the future where we actually use a Cypress because I know that uses JavaScript, and so it'll be quite a learning experience. Getting familiar with like JavaScript from basically scratch, and then doing it. Yeah, that would be pretty interesting. But yeah, Rust. Oh, so you can use it for a lot of stuff apparently. Yeah, I haven't heard too much about it, but that's cool. What do? But yeah, I wanna. What is Rust programming primarily used for? Like, what do people use it most popularly for? Oh, interesting. Oh, it's a low level. Okay. Oh, wow. Wow, that's pretty cool. I've I've always wanted to also like test hardware and see how to go about doing that. I think that would be pretty cool. Well, yeah, in the future. Like I know if you do like if you try to like test cars, maybe that's one way to get into testing hardware. Start with testing software on cars, and maybe that gets you closer to the hardware side. Okay, so it's not just me that thinks JavaScript is a little bit. I know some people that really love it though. Yeah. But yeah, glad we're in the same boat. Yeah, but for me, it's mostly just bias. Like I haven't used JavaScript a lot, so I hate on it, even though I shouldn't. Um, okay. Okay, so I think we know how to use fixtures. Um, and okay, this is pretty good. So these are all for like the arranged steps. Um, and so what we wanted to try to do was basically have a before all test. Um, and we did look at an example for how to do an after all test. I'm just not sure if that's the right way to do it. So I may have to do a little bit more research on it. But in terms of making progress, I think we should be able to write our fixture in order to get this test to run. Basically, the fixture is trying to set up the test. And what the test needs is to have a browser and a page open, so a tab. I'm trying to think because in previous stuff I wrote, we only created one browser session. We didn't create a new browser session per test. Or did I? Anyways, I think we can try it and just see how it goes. We can always modify it later. We don't need to like go too crazy, I guess. Since it's still a very small project, like we won't make massive changes if we need to like redesign. So I'm not too worried about just trying it and playing around. And like yeah, well maybe we're not doing it the like the correct approach, but then we can always change it later and then like learn from like why that wasn't good. So yeah, it won't be too bad. I think it'll be a good learning experience. I think we good. I think we fully understand this now, so we should be good. This was just to try and understand what fixtures are and how to use it. You basically using the function signature. So let's keep it for now while we modify this to use fixtures. So let's have one. So there's a keyword called this. Well, I might as well just copy paste it. Pytest fixture. We need to import Pytest. You need to move your mic if you lean. Oh, my bad. Okay. Yeah, I'm using a snake. Hope this is better. Okay, so we're doing a fixture. Let's just call. I don't think you need special namings, or just call it prepare page, or like start. Let's just call it start page for now. So what we want to do is we want to set up something looks off, but let's just see what happens. I don't know if I want to do this for every test, like create a new browser for every test. wait, this is this is the wrong one. This is the one. Okay. Okay. So we're like creating a new browser for every page. And then this will launch a new page. And then we're gonna return the page. So then here we'll just do I'll call it launch page. This is a little bit weird. Do I want to create a new browser session per test? Actually, yeah, because I think in the future, if we add like video recording, it will. A page is just a tab in Playwright, so we do want a separate like a separate window. So I think this should be fine. But should be fine. Let's just see how it goes. Page. I don't like the word. I don't like the word. Okay. All right. Let's see what this does. Hopefully it runs. And so we don't have an after test, so it's gonna close as soon as it finishes. But hopefully it's slow enough to actually see what's going on. Let's see if it works or not. Yeah, this is like my fourth stream. Like I try to do games on the weekdays because I work and then I probably don't want to do more coding after work. So I try to play games. Valorant's pretty fun. League of Legends. But then on the weekends and weekdays, I do want to practice. And I think I'll also try and do some of those league code challenges. That'll be fun. But on the weekends and like Friday, because I don't think I can handle it on the weekdays. I need some time off, you know. Event loop is closed. Event loop is closed. What happened here? Fruit salad. Why is it calling fruit salad? I should only have one test. Okay, I'm gonna get rid of this. I was supposed to comment this out. All right, so I'm sure it'll fail still, but at least we can see what happened. That was so quick. It should be a lot slower. Okay, so let's see what was the error. How do I clear this buffer? Oh no, that's not what I wanted. I just want to get rid of this. Okay. Let's do it again. So we saw a really quick browser window pop up, but it was I don't think it ran the test because it closed way too quick. Okay, so wow. Okay, let's just go very carefully then, because we can't. Page go to was never awaited. Okay, I think I understand. Okay, so we can't use it this way. There's another way to do it with Playwright, which is just calling launch, I think. Launch. Let's look at the get started. I think they updated their site because last time I checked, they had a different way of launching. Alright, but yeah, I'm pretty sure I can remember this. So let's not do this. P dot chromium dot launch. Like this should be enough, right? Not P, but Playwright. Well, I gotta remember it. No. Oops. Alright, let's look at the launch. Because that's what I think we need. Okay. Should be this one. Browser type dot launch. Playwright dot chromium dot launch. Do we need an instance of Playwright? Or does it already come with it? Let's see what this actually does. Okay. What is wrong with this? Oh. Okay. Let's reformat. Cannot find reference. Interesting. Passing Playwright. There's a... I forget. I wish I could find it. Try clear. Yeah. Yeah, I use a Mac primarily, so when I got a Windows just to do gaming, I had to relearn all the PowerShell command prompt commands. It was a little bit of a learning curve. All right, so this is close, but I don't remember. I will look it up, but let me see. We don't have Playwright initialized, so yeah, we need to initialize this somehow. But this is one way that they say, but there was another way. Trying to remember. Oh, okay. Actually, I think I do remember. I remember they don't tell you. They don't tell you this in documentation to do it, but I think this is how you get an instance of Playwright. Shadow. Let's just call it P then. I think. Yeah, at this point I'm guessing I should really just look at the documentation. Oops. Context manager object has no attribute. Okay, yeah, that's not the. What does P contain? P.start. Start. Is this what we were missing? That's start. You get a context manager, and then the context manager has the Chromium. I think this would be it. Let's see. Pytest. Okay, alright, finally. Yeah. It took me a while to figure this out because I didn't want to use their approach. And then just and also I was a little bit too lazy to look it up here, but I kind of got the hint because